All right, welcome back. Uh, Hopefully, you have a fairly decent understanding of naming straight chain hydrocarbons and hydrocarbons with branches. If you don't feel comfortable about those, please go back, take a look at those notes, and review the worksheets. Because without a firm foundation of that, this is going to be a little bit more challenging. So we are going to need reference table R on top of the other ones we've been using, P and Q. So please go to table R. It is on page 8 of the reference tables. We're going to deal with functional groups. So I don't know what you have at home. If you have a vacuum like this one, our vacuum doesn't look exactly like that, but most vacuums come with many attachments. So you notice that in this picture, you've got the flat brush, probably for hardwood floors. And then you've got this bristly one for maybe, getting the pet fur off your couch. Then you've got this attachment that you would attach for corners. Then if you need to go for longer, you would take this long piece. I don't know what this is for. Maybe just smaller areas. So depending on which of these attachments you add, the function of the vacuum changes. I know in our vacuum, we have one of the heads for carpet that has like big brushes, and then we have a flat one for hardwood. So different functions with different pieces. That's kind of the idea of a functional group. So we're going to take off some of those H's, those hydrogens, and instead replace them with another group of elements or compound or groups of atoms. And it's going to change the function. It's going to change properties. It's going to change lots of stuff. And if you see on table R, we have many different compounds with different functional groups. It will change how they're drawn. It will also change how they are named. So we're just going to go through a bunch. There is a lot to know here, but thankfully table R will be available to you, and they give you those examples, and that should be pretty good. And there's going to be lots of practice on the internet, so if this isn't enough, please search for more. All right, the first kind of functional group we have is called a halide. If you notice on table R, they're also called halocarbons. Halo meaning halogens. So if you look at the functional group, it says we've got F, Cl, Br, and I. Those are the halides. And imagine taking one of those H's off. So H comes off, and instead we replace it with an F, a Cl, a Br, or an I. If we add an F, it's going to change to fluoro. That's going to be a prefix. Where am I finding this? Table R. Cl is chloro, Br is bromo, and I is iodo. Take a look at the general formula on table R. What is R? If you look at the bottom, it says any group of atoms, a bonded atom or group of atoms. So just imagine that's our carbon chain. It could be 3, it could be 3,000 carbons long. So we've got some carbon chain and a halogen attached. So that's the general formula. And then I love that they give an example. They give you the name and how you would build it. So let's talk about some of mine. Oh, so can't see it. All right, so let's practice doing some drawing. Okay, I will choose something to contrast with that blue. So how about magenta? CH3Cl. So remember, carbon always has to form 4 bonds. For the sake of differentiation, I am going to draw the H's. Does it matter where they go? No. Remember, this molecule is going to rotate around in space. And so here's our Cl. Now, technically, you should put valence electrons. I really think you should still do that, because really, they don't look the same as H's. So here we go. So we have CH3Cl. So we need to name it. First of all, the longest parent chain is only 1 carbon, and they're all single bonds, so this is methane. But it's not normal methane. It has a Cl. So look to table R. What do you call when you have a functional group with a Cl? Chloro. Chloromethane. Do I need to put a location? No, there's only one carbon. So putting a 1 here is redundant. This is called chloromethane. Let's try the next one. CH2Cl2. Maybe I'll use a different color just to keep them separated. Green. See? 1, 2, 3, 4 bonds. 2 of these bonds will be to H's, 2 of them will be to Cl. Doesn't matter where you put them. I'm just going to put them here because it's going to give me more space. Doesn't matter. Things rotate. Chlorine. Put those extra valence electrons, as you see. Now let's name it. Still the parent chain is methane. This is a chloromethane, but there are 2 of them. How do you indicate 2 chloros? That's dichloro. And this is one word, dichloromethane. This is one word, chloromethane. How's it going? Good? Let me choose a darker color. How about just blue, I guess. CH2F, CHF, CH3. So there you go. CH2 and an F. Doesn't matter where we put them. I'll put it here on the end just to give me some more space. But you could put it here. You could put it here. Doesn't matter. And remember, you don't actually have to write the H's. It's understood as organic chemists that they're there. I'm just showing you that to compare. So CH2F. Good. So that's done. Then we need a CH. And then we need an F. That's 2, by the way. Now it looks like 3. It's just 2. Then we have a CH3. Okay. Let's name the parent chain. Meth, eth, prop. Wait a second. Where do I find all of those different prefixes? Oh, that's table P. So prop. All single bonds. Ane. Propane. Now, I have to look for my functional groups. I have a fluoro here and a fluoro here, which means I have a difluoro. And by the way, this can be one whole word. I just ran out of room. Now, the last thing we need to do is give a location of those fluoros off of which carbons, because if they are on the same one or different ones, it matters. We always give the numbers on the lowest ones possible. So let me number them this way. 1, 2, 3. Then let me number them this way. 1, 2, 3. If I number them left to right, I have a 1, 2 difluoropropane. Those are low numbers. If I read them this way, it's a 2, 3 difluoropropane. And 1, 2 is smaller than 2, 3. So it's going to be a 1, 2 dash. Location, 2 of those, parent chain. All right, now I truly apologize. This last one you can't see, but it is in your book. Why would I ever want a white pen? Let me go back. Black. CH2F, CHBr, CH3. I'm going to squeeze it in here. CH2F. I think I'm going to put the F here. This should just be 2 dots. Sorry about that. Got messy. CH2F. CHBr. CH3. Okay. I think I'm going to erase some of the stuff up here just to give us more room. Hopefully you don't need that anymore. All right, so now we need to name the parent chain. Meth, eth, prop. All single bonds, we have a propane. Look for our functional groups. We have this and we have this. This is called fluoro. This is called bromo. Who comes first? Well, look on table R. Who is at the top? It's fluoro. Fluoro is more important. So fluoro is going to be off the first carbon. So we call it 1-fluoro. Bromo is on the second. 2-bromo. Propane. So bromo propane could be the whole thing, or you could have a little space here. I suppose it doesn't really matter. That's a halide. Any questions? Go back, read it again, watch it again. All right, next one, we have alcohols. So alcohols, these are when you have a hydroxide, OH, minus, replacing the H. So we have all those H's on our parent chain, we pull one off, we put an OH. So OH is called hydroxide. When it becomes a branch, we call it a hydroxyl. So some characteristics of alcohols. Alcohols are what we call a non-electrolyte. They do not conduct electricity. They do not break apart or ionize in water. They're not acid. They're not base. They are different. What's the pH of an alcohol? Forget it. It's not going to give you that. These are polar molecules. Remember, polar molecules are asymmetrical. And that also means that they would dissolve likes, so they would dissolve in water. They should anyway. So this is not on the regions too often, but I'm going to include it anyway. You can classify alcohols, where the hydroxyl is attached and how many are attached. So let me just kind of plow through this and then we can draw. So we have a primary alcohol, a secondary alcohol, and a tertiary alcohol. In a primary alcohol, we have an OH group, the hydroxyl, attached to one whole group of other things. Remember what R is? R is just a group of atoms. We don't care how long it is. So this means attached to the OH, we have one group. So butanol. Oh, we haven't learned how to name an alcohol, but you'll notice that OL, all, indicates that's an alcohol. So bute, meth, eth, pro, bute, 4 carbons. 1, 2, 3, 4. If it says 1, that's the location of our OH. Make sure the bond goes to the O and not the H, because H can only form 1. And then all of these are H's, but now that you're an organic chemist, you don't need to draw them. We understand. So notice that off of the OH carbon, there's one chain. Secondary carbons, 2 R groups are attached. Remember, R is just a group. So let's draw 2-butanol, and then you'll see it. Meth, eth, prop, bute. Off the second carbon. By the way, since I'm drawing it, I decide who is the second carbon. I can make this the second carbon, or I can make this the second carbon. I'm drawing it, so I decide. So I'm going to put it here. And then don't leave it like this. Put your H bonds there. Carbon always has 4 bonds. Now, notice that we have, off of the OH carbon, we have one group here, and we have a second group here, 2 chains. So off of this, that's why it's called a secondary alcohol. 1 chain, 2 chains. The tertiary alcohol, is when you've got 3. 2-methyl, 2-propanol. All right, let's try this. Meth, eth, prop. What is a methyl group? Methyl group means a carbon, CH3. And also off the second, we have an OH. This is confusing. Well, it might not be on the regions, so just relax. All right, now, how many groups are coming off of the OH carbon? There's one group. There's another group. There's a third group. That's why we call it tertiary alcohols. How many are there? All right, let's give it a draw. CH2, OH. Where do I want to put OH? I don't care. I'll put it here. Don't attach it to that H, though. Check. All those are done. CH2. Check. CH2. Check. OH. All right, meth, eth, prop. Now, we're going to learn in a second, but if you don't want to wait, take a look right now on table R. To end the suffix of an alcohol, it is OL. So propane would become propanol. So now let's find the locations. Oh, wait a second. We've got 1, 2 alcohols. So we're going to actually change our name, not a propanol, but a propanediol, as opposed to a dipropanol. It's called propanediol. Now, where are they located? The first and the third. Or is it the first and the third? Guess what? Doesn't matter. Location. If there are 2, location. All right, so we've kind of talked through some of these. To name an alcohol, what did we do every single time? You find your longest continuous parent chain. Count your number of alcohols. Indicate the location of the alcohols. Use the lowest number. It becomes OL ending. Oh my gosh, you can't see this. If there's more than 1 OHs, it becomes a diol, a triol, etc. It's in your notes. Well, it's in the PowerPoint slide notes. All right, let's give it a shot. CH3OH. Now remember, I'm going to, for the sake of time, not write in my H's. They could be, any of these could be H's. Doesn't matter. All right. How long is our parent chain? It's 1 carbon long. So it would normally be methane. However, we're going to change the ending. Notice that it is an alcohol. So we change the ending to OL. Methanol. Okay, now give the location. No need. There's only 1 carbon. Methanol. CH3, CH, CH3. Ugh, here we go. CH3. Check. CH. Check. OH. Check. CH3. Now, what if you put OH here and the CH3 here? That's fine. The parent chain can bend. 1, 2, 3 across. Meth, eth, prop. Not propane. Now we are an alcohol. This is called propanol. Propanol. Okay, now, what is the location of the OH? 1, 2, 3, 1, 2, 3. Either way, it's off the second. 2-propanol. Here we go. CH3, C. Now, see how it says 2 groups of OH? OH here. Oh my gosh. OH. OH here. Don't connect it to the H. Connect it to the O. That matters. CH3. This looks pretty similar to that one, except for there are 2 OHs. So what does that mean? We call it a propanediol 2. Where are they located? They're both off the second. Do I really need to say 2-2? Yes, I do. Because if there's a di, where are both of them? They could be here and here. That means the location. If I put one here, it would still be a diol. Put the location. That matters. Last one, CH3. So messy, I apologize. CH3, CH, OH, CH2, OH. This is exactly what I was just alluding to earlier. Once again, we have a propanediol. However, where are those alls? They're located on, is it the 2 and the 3? Or is it the 1 and the 2? Oh, it should be the 1 and the 2. You number them in the way that they have the lowest numbers possible. So if I numbered them 1, 2, 3 carbons, it would be off the 2 and the 3. But if I went from right to left, 1, 2, 3, it's the 1, 2. All right. And the last functional group for today, aldehydes. Take a look on table R, aldehydes. We have a C double bonded O to an H. It's at the end of a carbon chain. Remember what is an R? That just means a bunch of carbons. So since it's always going to be at the end, you don't have to give a location. Remember how we had to say like 2-propanol? We don't need a location because it would always be on the ones. How do you name an aldehyde? Look on table R. Looks like we're ending them with AL. Aldehydes end with al. So we're going to have things like methanal, propanal, butanal, ethanal, propanal, butanal. Okay. All right, let's do it to it. CH3, CHO, CH3. I'll write them in. C. Now remember, carbon needs 4 bonds, and this already is 1, so we need 3 other bonds. So if I do this, CH3, CHO, I can't do that. I got a bond to nothing, and no, that's not how we do it. Which means what? There's not going to be 3 different bonds. We're going to have a C double bonded O to an H. But wait a second, it doesn't say OH, it says HO. I know, just relax. Meth, eth. Normally this would be methane. However, this has an aldehyde. So I get rid of this, and I write ethanal. Do I need to put the location? No, it's always at the end. Then I have CH3, CH2, CH2, C. I've only got 2 things coming, and I got 3 bonds. Gotta be this. That's an H. This is not a double bond. This is a single bond. Meth, eth, prop, but, butanal. Okay? Finally, the last ones, ketones. Ketones, take a look on table R. This is a C double bonded O somewhere in the middle. The middle of a chain. If it's in the middle of the chain, we need to give a location. Do we have to, how do we change the name? Ketones. Take a look. Why am I saying ketones? It's because the ending is going to change to O-N-E. O-N-E. Methanone, propanone, etc. Pentanone. Okay. Here we go. CH3. CO. CH3. Well, I know it's got to be this, so this has to be ketone. Meth, eth, prop. Propanone. Which carbon is the interior one? This one. It has technically, okay, so let's argue for a second. Technically, you give a location for a ketone, but isn't this the only interior carbon? So really, in this specific case, you don't need that. Normally you would, though. You see what I'm saying? Because if you put it here on the end, it wouldn't be a ketone. It might look like an aldehyde. So technically, this is not necessary. I wouldn't take points off. CH3, CH2, CO, CH3. By the way, the more you practice this, the more you'll see it. Meth, eth, prop, butane becomes butanone. All right, last thing we got to do is give location. 1, 2, 3, 4. It would be 3 butanone. If I number it this way, 1, 2, 3, 4. Oh, it would be 2 butanone. So it's got to be 2 butanone. Remember, you always number your carbons so that they're the lowest number possible. So you can go right to left because things rotate around. Okay, guys, I know that was a lot of information. Do your best to unpack, and we'll meet again soon.